We begin with defining area of a rectangle as the product of the length and width. So if this is what we call L and this is W, then we just say area equals L times W. You multiply these two dimensions. Now you can use the same idea for a square. In square, both of these dimensions are going to be equal. So instead of length times width, you would say side times side. All right, so area of a rectangle is taken as area of a rectangle is L times W. So this is our first formula. And now we try to find area of a maybe parallelogram. So what is a parallelogram? A parallelogram is somewhat similar to this rectangle, except that you need not have a right angle over there. So it might be slanted. And then we don't use the words length and width. Maybe we want to call this as base, B. And this slant dimension is of no use. Instead, we measure, and these two sides are parallel, we measure the distance between these two sides and we call it as H. Now, if you notice, area is nothing but the room inside. If this is like a playground, you want to know how much room you have to play. So, area is what's inside here. And notice that if I were to imagine cutting this piece and putting it here, these two are going to be congruent pieces because of the way a parallelogram is. It's these two sides are equal and parallel. So you can imagine cutting this and putting it here. In that case, the area is still the same as area of this rectangle. So what's the area of a parallelogram? It's going to be base times height. Instead of length times width, you're going to say it's base times height. So that was easy, but let's look at a triangle. Now in a triangle, what you have is only three sides. And which ones do you want to count? Well, just like for the parallelogram, let's call this side as base, and then again we want to use the height of the triangle. Now, how much room do I have in here? Now, here is what I can do. Actually, let's look at a right triangle to begin with. In a right triangle, it's easy to see if I'm going to use the same. I have a right triangle. If I use B and H, base and height, then it's easy to see that this is half of the rectangle. So if you imagine completing this rectangle, let's draw with a different color. So you can imagine this area is the same as the one that's inside the triangle. So whatever is outside is the same as what you have inside, which means each is half of that area of the rectangle. Area of the rectangle is B times H. So area of this triangle is half times B times H. Now, can we use the same idea to do that in a general triangle? Yes. If you can draw a parallel line to the base, then you can see, and again, put this triangle in a rectangle this way. And then notice that whatever area I have here is the same as area here. And let's again use different colors. So say this area is now same as this area. So again, you can see that these two areas together is equal to these two areas, because these two are same pieces and these two are same pieces. So whatever is inside the triangle, you have the same area outside the triangle. And the rectangle that you have drawn has dimensions b and h. This is also h because this is h. So area of the triangle here also is going to be half times base times height. So we have a formula. So we started with area of a rectangle, L times W. Then we have found area of a parallelogram is base times height, and triangle is half base times height, because triangle goes to a point. You don't have two solid bases like in a parallelogram. You're going to have only half as much room. Now let's look at one other shape which is somewhat like a parallelogram, but it differs from a parallelogram in the sense that now the two parallel sides, the two bases, are not equal in length. You have a pair of parallel sides, and say you have bases of B1 and B2. And again, you can, whenever you have parallel sides, you can talk about the distance between them, and that's h. So if you don't have here, when you had equal bases, so this base was also b, you just multiplied base times height. But here, if you're going to say base times height, which base are you going to consider? If you consider this base, you're going to get a bigger number. If you're going to consider this base, you're going to get a smaller number. So how are you going to find the area of a trapezoid in that case? Now, you can prove it if you want. If you don't have equal bases, then what you do is you take the average of the bases. So what is the average? How do you get the average of two numbers? You add them, b1 plus b2 divided by 2, and then divide by 2. You add and then divide by 2. Now this is the average base of the trapezoid, and then you multiply by h. So that's the formula. The bases are not same. You take average bases times height.